this is a word problem, and you're given the velocity in terms of the radius. And the picture that you see is the picture of an artery and blood is flowing. The velocity in which it's flowing is given to you as the 18,500 times 0.25 minus r squared. R is the radius of the artery, and this is the independent variable, and V of R is your dependent variable. So if you graph this, along the x-axis will be the radius, and along the y-axis will be the velocity. Okay, and the information given here is the velocity is greater along the central axis and decreases as the distance r from the central axis increases. And the formula is given to you, and the radius of the artery in this information is 0.5 centimeter. Velocity is in centimeter per second, and radius is in centimeter. Those are the units that I have to keep in mind when I finish my problems. Okay, so the first question here, A is asking you to find the value of V when your radius is 0.2. So in other words, it's technically asking you to evaluate the function at 0.2. So what I have to do is just plug in 0.2 in the place of r. So this would be 18,500 times 0.25 minus 0.2 squared. I can put 0.2 or 0.2. Can you use my calculator for this? So if I go here, 18,500, open parentheses, 0.25 minus 0.2 squared. I don't have to, I'm not using parentheses. It's okay. If I use parentheses, that should be fine too. So here I'm getting the velocity is 3,885 centimeter per second, and that's what we should go here, 3,885 centimeter per second. And the second question is, the second part of it is asking me to find what the velocity would be when your radius is 0.3. So 18,500 times 0.25, and now in the place of r I have to put 0.3 squared. Again, use your calculator. Now a shortcut here would be I can go up, highlight it, enter, and just go and change this 0.2 to 0.3 instead of typing this whole thing. So the answer is 2,960 centimeter per second. That's what should go there. Okay. So the second part of the question is, what do your answer to part A tell you about the flow of blood in this artery? So from this choice is given, the correct choice is A, because the blood flow is much faster, and we can see that the number here is bigger. The velocity at 0.2 is 3,885, and the velocity at 0.3 is 2,960. Therefore, the blood flow is much faster 0.2 centimeters from the center than 0.2 centimeter from the edge. Okay, the third part of the question is filling this table up. Now here I do have the two values already, so I know what when it is 0.2, and I also know when it's 0.3. So because I already found that, so I can use those values here. So this would be 3,885, and this would be 2,960. Now I need to find when it's 0, 0.1, 0.4, and 0.5. So I'm going to use my calculator. Again, going back, highlighting it. When it is 0, I need to replace this 0 and make sure I have to delete this decimal point. Yeah, so it's 4,625. (4,625 centimeter per second). And I'm going to take that in. When it is 0.1, Need to replace the 0.3 to 0.1. So 4,440 centimeter per second. And for 0.4, I have to replace this 0.1 to 0.4. So just change that to 4. It's 1,665. And for 0.5, just replace the 0.4 here to 0.5. And I get a 0. Okay. So the last part of the question is asking, what is the net change in velocity v as r changes from 0.1 to 0.5? So technically it is the change in the velocity. That's what net change in the velocity, that's what it's asking for. So in order to do this, I will have to go and take this value of the values and subtract it. So technically what I have for 0.5 is the velocity is 0, and for 0.1 the velocity is 4,440. Therefore the net change would be velocity at 0.5 minus the velocity at 0.1. So velocity at 0.5 is 0, at 0.1 is 4,440. Therefore the answer is negative 4,440 centimeter per second. Okay, and that's the first problem.